let's go ahead with the today's agenda. So if we're talking about the day 6 agenda or the today's agenda, so we'll be starting with the data cleaning and pre-processing in R, which means how you can clean your data in and pre-process your data in R. Then we will be talking about the data visualization with ggplot2. Like if you see the job description of few companies, so you will find that in the data visualization topic they mention the ggplot2. So that is the power of ggplot2. You will find that most of the data visualization, in the job description, when it comes to data visualization, they mention few things like Tableau, Power BI, right, Plotly, like for Python. Like for R there is ggplot2, as well as the R shiny is there. That is nothing but the somewhat similar to the Flask in Python. If we're talking about the basic statistical concepts in R, so we'll also see these concepts, as well as we also see the advanced statistical concepts in R. Okay, like how you can implement the regression. Okay, that is, we can say that the and how we can find out the uh, you know the confidence interval, prediction intervals in R. So that we will gonna see in the today's session. Also we'll talk about the ANOVA, analysis of variance, and the non-parametric methods as well, and how you can go ahead with. And lastly we'll be talking about the time series analysis. Okay, like few who do those who don't know what is time series analysis is, basically in the time series analysis, okay, we have the data which is totally arranged in a timely manner, like a weekly data or monthly data or yearly data you will find. And we have some algorithms in time series itself, so you can apply those algorithm to go ahead with for the forecasting part, or in short you can say prediction part, right? So guys, let's go ahead with our agenda and explore this one by one, this all the topics. So guys, are you ready? Have you installed R Studio and R in your system? How many of you install R Studio and R in your system? So today we'll be working with the R in R Studio. So that's why we need R. As we know in like in the previous session, now we'll be using first dataset, which is nothing but the company dataset, and we'll be exploring that dataset, which means that we'll be cleaning that dataset, right? So let's go ahead. Like there are few steps to simply go ahead with that particular dataset. So like over here, like I can simply start writing the code, or in the first initially, if you don't know how to read the dataset, so you can simply use this the automatic option. So here you will see that in the R Studio there is import dataset option is there, like in the environment. If you see over here, see here we have a import dataset option. Now you can simply use the second option. Okay, like if we're talking about the CSV file, so we'll be able to read the CSV file by using this particular function, read underscore CSV, right? So now let's go and find out the data that we wanna basically insert. Now for that, what we can do is we can simply go over here in the day 6, and simply I'll be clicking to this particular data set, which is nothing but the company data set, and I simply click to open. And now here you will find that automatically, okay, my code is ready. Automatically my code is ready over here, and this is how my data looks like. If you see, this is how my data looks like. So here you will find that starting with the first column with the name, nothing but the account number, then we have the account name, status, gross income, then now wages, then complete and date. So here you can see that. Let's go and import the data set. So basically we click few these things. Okay, like first row as the name of the columns, like this. Okay, like we did few things. Now let's go and import it, and here you can see we got the data, okay, in the view. Now let's go over here, because okay, this is the initial step to read my data set. That's why we don't have any code over here. So we can simply copy this code from here, just for you, because I'll be sharing this particular file with you, so you will understand all the things about the how you can read the data, how you can collect the data, right? So let us go ahead and read this particular data, right? So this is my the code for reading the data, and this is of simply, here you can see that the library, with the help of this particular library reader, okay, I simply able to read this particular data which is in my particular folder. Right now, what I can do is I can simply, okay, many times you will find that, okay, like lot of data, like almost all the data, you will see that that is in my particular this particular column, which is nothing but the day 6 column. And here you will get the all the 4 data set. You will find that company data set, oscillation index, then we have the tightening and WCAT data set we have. Right now, what we can do is we can simply put one thing over here, which is nothing but the set wd. So set wd is for the setting the working directory. Now here you can see I'm just setting my working directory over here in this particular folder, because each and every time I'll have to read the data from that particular, from this particular path. So instead of adding this particular path, okay, like each and every time while we are reading the data, so instead of this we can simply use this one line of code for each and every time while we are reading the data set from this particular path. So what I can simply do is, okay, let's again clear this particular thing and again clear this environment as well. Okay, now here if you go and you just click to this set wd, just click anywhere on this particular line and simply go to the run. And here you can see, let me show you. Now we just able to change our working directory. So for that we can simply see the our current working directory by using get wd. Okay, by using get wd, just use control plus enter to run this particular line of code. Otherwise you can simply use this option as well. Now here you can see I just change my current working directory from any different working directory to this particular path. Means now this folder is my current working directory. So this folder is nothing but my this folder, and here you will find that all the data set, right, which we will be using for the particular in this particular session. Right guys, now let us go ahead and, as we know, let's go and read this particular library, which is nothing but the reader library, to read the data set. Second thing is that read the company's data set. Right, this is my company's data set, and to see my company data set, what I can do is I can simply click to this particular line of code, which means view company's data set, or I can simply click to this option in the second window. If you see, like the company data set is there, total how many observations are there, 27 observations are there, and total 7 variables, which means total 7 columns are there. Right, so let's click to this instead of going with this view code. So for that, okay, because like I'm showing you the multiple ways for doing this particular thing. So here you go. Now basically if you see, like as we discussed earlier, in my data set we have the total 7 variables, which means 7 columns we have. And if you see in my data set, there are few missing values are there. Okay, there are few missing values are there, na values. So na values are nothing but the missing values, right? Okay, so now simply we'll pre-process this all the data set. Okay, we'll go ahead and we'll clean all the data set. Okay, so okay, that's why I'm showing you this data set frequently. Now let us go ahead and now starting by the initial state, or you can say that the initial exploration of your data. So like in the initial state, what are the different things you can do? You can go ahead to see your data, how your data looks like. So just by looking out the data, you can see that the many things you just notice. Okay, like the how many categorical variables are there. So if you see account number A, B, 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 C like this is a categorical variable. Account name is a categorical variable, means the text data you see. Status is categorical variable. Then we have the complete yes or no, not like this. See, this is again the categorical variable we have, right? This is a date time feature we have, like, so you will find that so many different things. So just by viewing the data, now after this, after viewing the data, so if you see that, we can simply go and find out the summary of my data set. Okay, we can simply go and find out the summary of my data set. So what I can do is I can simply go ahead with summary. Okay, I can simply go with summary. If you see, okay, just enter it, and in the summary just mention the data name, which is nothing but the company data set. So here if you find, okay, I got the data set with here one option. If you see, okay, like this is showing me all the data set, right? This is showing me all the data set. So let's go and click to this, and let's go and run this. Now if you see, right, we got the all the summary for this all the data set. How many columns are there in my data set? Total 7 column, isn't it? So here you see starting with the account number. Okay, because account number is nothing but the character or categorical data in short. So you will find that, see, because of the character, so it just show me the class and mode for this particular thing. And like it's not able to get any summary for from that particular categorical variable, because if you see in the summary, what are the different things we are calculating? Like we are calculating the mean, quartiles, median, maximum value, right? So these are the different things we are gonna find out by using the summary, right? So if the data is, you know the categorical, then we can't go ahead with, and we can't find out the mean for this particular data. Let's say account name, we can't find out the mean for this particular data, right? Okay, also for the status, we can't find out the status for this mean for this particular variable, right? But we can find out the mean for this particular gross income. We can find out the mean for particular this num wages, right? Right. So these are the different things we can do by using this particular simple line of code, which is nothing but the summary and our data set name inside it, right? So for that first three columns, if you see these, all these first three columns are nothing but the categorical. That's why you can see that the only characters are here. Now in the second thing, if you see that we have the gross income. Now basically minimum value for the gross income is going to be the 1. Maximum value is going to be a very high. Okay, like there is e raised to plus 13, which means that after this digits, okay, go after 30 digits. Okay, so 1450, then you will find that the around 9 and then you will find that that particular point, okay, or the decimal point you will see. So that is a thing, because this is a company's data set. So you will find that the uh, like maybe the gross income for the companies may be in the billions, right? Then we have the wages. Okay, number of wages if you see. So here you can see that we have the first quartile, the minimum value is simply 0, we can say, and maximum quartile, maximum value is going to be the 6-digit number. Okay, so that is the thing. So if you see over here, how many NA values are there? How many NA values are there? Like, let me show you over here. Okay, how many NA values are there? One value, right? So we can simply find out the is there any missing value or not by using the summary as well in our studio. So let's go over here and see is there any missing values or not. So we were talking about this particular thing. Okay, this particular column. Okay, so here you can see that we have the missing values present, like how many NA values are there. So if we're talking about the different categorical columns, so we can't find out the missing values by using this particular line of code, which is nothing but the summary of the data set, right? So after understanding the summary, let us go ahead, okay, and see the structure of the data. So how you can see the structure of the data by using the structure method. Okay, just use the str to get the structure of your data. Okay, now if you see, this is my company data set. Let's double click to this, and here you can see, let's go and run this. Now basically we got the structure of the data. Okay, we got the structure of the data. So if you see that we have the structure, like we have the first few columns, which are nothing but the categorical columns, right? Then we have the two numerical columns we have, and then we also have the categorical column after that. Okay, so if we're talking about the names for those columns, so you will find that these are the names for these columns, and you will find that the, you know, those columns which are categorical, so you will find that the columns character. Okay, and those columns which are nothing but the, you know, the numerical one, you will find that the columns double, right? So that is the difference over here. Now after these, okay, let us go ahead and understand the further part of the data, right? So let's say if you wanted to you know, find out the types of data structure in R. Okay, here you will find that the data structure, how you can see the data structure. Now if you wanted to find out the types of data structure, so you can simply go ahead with class, and you can use your company data set. Okay, and let's go and control plus enter. And now here you can see the type of your data frame is going to be the data frame. See, is going to be the data frame, because we imported this particular data frame, okay, from this particular CSV format. Okay, so basically here we got the data frame. Okay, like itself, the structure of this, the type of the data structure for this is going to be a data frame, right? After this, how to find out the shape of the data? Anyone anyone Like in Python, if we wanted to find out the shape of the data, simply we use the argument which is nothing but the our data frame dot shape, right? But here, if you wanted to find out the dimension or shape of your data, so how you can find out? Yes, absolutely. So like not the shape, definitely DIM. By using the dimension, we can simply go ahead and find out the shape of the data. If you wanted to go ahead with, you know, find out the shape, okay, or the dimension of your data, you can simply use the dimension. Okay, so DIM, you can simply say this. Let's go and run these, and here you can see, okay, like for not for this, in the console you will find that, okay, this particular thing over here, guys. Like this is nothing but the dimension of the data. So if you see that total how many observations are there, so if you see, so there are total 22 observations are there, and here you will find that total 7 variables are there and total 7 classes are there, right? Now after this, okay, uh, what are the different, you know, the exploration, visual exploration you can do? Like we can plot the histogram, right? We can plot the box plot, right? We can plot the bar plot, yes, and we can do so many different things, but like we will see all those in the, you know, in the data visualization using ggplot2. But for now, okay, we'll be talking about the, you know, the few plots. So first let's go and plot the histogram for this, okay, to show you. So here you can see that, okay, I'm just plotting the histogram. Hmm. Now I just wanted to go ahead with one simple column. Okay, so let's say if I wanted to go ahead with the, you know, the gross income. So this is my code, and let's go and run this. See, in the gross income you will find that the this is going to be the histogram. So if you see, if you wanted to zoom this particular thing, so you can see the your gross income like this. Okay, like for all the company, if you see, like most of the companies, okay, have the gross income is around, somewhere here. Okay, and for just few companies you will find that the gross income over here, right? This is nothing but the gross income for the companies, right? So if you wanted to understand, this is nothing but the frequency, which means how many companies, okay, having the gross income like this, how many companies having the gross income like this. So if you see the frequency for this particular, you know the bar, I can say, so here more than 20 companies you will find that the, having the gross income which is less, but only few companies which is having a gross income, okay, like the 14 digits, like in 40 digits, if you see. So that's how you can read this particular plot. Okay, now if you wanted to go ahead with the further plot, which is nothing but, let's say, box plot, so you can simply go ahead with, okay, box plot. And again you can use the company data set, simply use the dollar symbol to just find out the, to just take or extract any particular column. So here we'll go with the this particular column. Okay, so let's go and run these, and here you can see the box plot. It's like the very much in the one line, like if you see, because, okay, like if you see over here in my histogram in my previous plot, so here you can see that most of your data is like most of your company having a gross income is somewhere which is, very much close to, very much near to zero. Okay, that is the thing. Okay, like the four digits value, 5 digit value, 6 digit value, like this. Okay, if we're talking about the, our box plot, so you will find like this, just only one line. Because what are the different things we can find out from the box plot? Like as we saw, what are the different things we can find out? We can find out this multiple things. We can find out the minimum value, we can find out the first quartile, the median, we can find out the third quartile and maximum value. Total 5 things we can just find out. Okay, now here if you see, because of the range is quite high, like if you, imagine the range for this particular thing. Okay, if you imagine the range, okay, starting with 0 to, there are, 5 digit value, 1 into e raised to 5, which is nothing but there is 5 digit value. So here if you see 2 into e raised to 5 like this, so which means that, okay, you will get the very very high value. Okay, so if you compare this range, so like let me like explain by drawing it. Okay, so let's say, okay, if you see this particular range starting with, let's say, 0. Okay, somewhere here we have the 0. So if you go ahead like this, so you will find that over here, okay, like 1 into e raised to 5 means 1. Okay, some fishing some issue, I guess. Okay, 1 2 3 4 5, right? So here you will find that the 5 zeros are there, okay, after one. So that's why 1 into e raised to 5. Okay, this value is. Okay, if you go ahead like this, so 20,000, 30,000, 40,000, like this up to so on. Okay, after so many digits, okay, after so many things, like somewhere here 1 into e raised to, okay, like here, like I am facing few some issues for drawing this. So what I can do is I can simply open the whiteboard, right? So simply open the whiteboard so I can explain this particular thing with you, because here you will see that the only a single line as a bar plot. Okay, and here you will find that the few points. Okay, this few points, anyone can tell me the, the interpretation or a few point, this point or this point somewhere here. If you see, these are nothing but the outliers. These are nothing but the outliers. Okay, so as I told you in the previous session, if you wanted to detect the outlier, you can simply plot the box plot and you will able to visualize are there any outlier in your particular column or not, right? So that's how you can see. Mm, okay. Okay, now here you can see, okay, what is the common shape for the box plot? Either if you see the box plot like this, okay, if you see, okay, and the box plot like this, right? This is my box plot and this is my, minimum value, you can say. This is my minimum value, this is my maximum value. Okay, if you see, this is my, okay, this particular thing, you can say this is my first quartile, this is my median, or you can say that the second quartile, right? And here you will see that the Q3, which is nothing but the third quartile. So if we're talking about the Q1, so you will find that the 25th percent observation, which means that from here, from this minimum point, you will find that how many observations are there. So 25% observations in this particular region, in this particular region. Okay. Then next 25% observation in this particular region, if you see, right? So that is why you will see that this is also known as a 50% or the Q2. Okay, and the next 25% observation in this particular region, that is nothing but the Q3. So that's why we also say it like 75 75th percent observation over. And finally, if you see over here, so you will see that the next 25%, this is for the normal range, right? This is for the normal range. Sometimes you might get the data, okay, like this. Okay, somewhere here you will find that the few data points, okay, and these data points which are nothing but the outlier, okay, which are nothing but the outlier, if you see. So in our case, okay, because of the range is quite high, okay, like let's say if we have the range starting with the 0, and then you will find that, okay, let me, okay, so here after this, if you see, we got the, let's say, 10,000. Okay, then if you see, go over here, you will find that the, you know the 1 lakh, right? After this, if you go over here, you will find that the values in, billion. If you see over here, so you will find that the values in, okay, so if you see the values is in billion, okay, like say, let's say 13, 1 into e raised to 13, which means that there are 13 zeros are there. Okay, so you will see that the values which are in billions, right? So if most of the, the gross income for the companies, okay, let's say will be like this, okay, that doesn't matter, because if you go ahead with the, the range for these, so you will find that this particular range is very high range. Okay, only few company you will find that the 2 3 companies, okay, over here. Okay, like we are talking about the Fang, and now we are talking about the Mang, right? The Meta is there, we have the Apple, Google is there, right? Microsoft is there, right? So these are the few companies you will find that the, if you see the revenue of this company, income of this company, you will find that the, this, the income for this particular company is very high. Okay, so if you combine the, the almost 80 or 90% company, rest of the company, you will see that the revenue is again high of this company, these 4 5 companies. So you will see that the few companies which are over here, few companies which are over here, those are, we can say that the startups and all, right? So that is the thing. So if you're trying to plot the box plot for this particular range, so just imagine this is my 0 and this is my somewhere here 1 plus or the 1 into e raised to 13. Okay, so normal range for these, because from this particular histogram, okay, if you see the histogram, okay, if you see the histogram, you will find that the only few companies which are there, and how many, like one or two, but most of the companies like 21 20 around companies which are over here in this particular region, right? So for that, okay, if you plot the box plot, so you will see the box plot like this, because the range is quite high. Range is quite high. If you plot the box plot in this particular region, okay, for this particular 4 5 digits, so you will see the box plot like this. Okay, you will see the box plot like this. If you're talking about only this much range, let's say only this much range, okay, you will see the box plot like this. But for full range, you will see the box plot like only one line, because this total box plot, okay, like the, if the maximum value, let's say, is 1 lakh, okay, but if you're talking about the maximum value for this particular range in billions, okay, so 1 lakh is like nothing in front of this big value, right? So that's why you will see the box plot like this, and you will see the, the values which are somewhere here. So those value, if you see, okay, like this particular value, if you see, so these values, okay, which are nothing but the outliers, if you see, right? So that's how you can identify the outliers. Understood, guys? Okay, so that's how you can just go ahead with and just find out the, the box plot, and try to understand, are there any outliers or not, okay, the range for the data set and all, right? Now let's go ahead and the fix the errors that we have in my data set. So error is nothing but the, let's say, the missing values, and or like the missing values are nothing but the errors. Okay, the errors either made by the machine or the humans. Okay, because let's say if you hired few people for, data entry kind of thing, so then you will find that, okay, like for humans error is always there, if you see. So like there might be some mistakes while, entering the data. So that's why you will see that the few data set which are few values in the data set which are missing. Okay, that is also nothing but the missing values, we can say. Now that is nothing but the error in your data, right? So let's go ahead and deal with those, right? Just find out the how many missing values are there, okay, and how to deal with that. Okay, now as we know in Python, okay, like how we just find out the missing value is null method is there, right? We just type this particular line of code, and what is that? That is my data df dot is null. Okay, that is the code, okay, that we use to write in the, you know yes, is null or is na, right? Is null dot sum. We are just finding out the like the, is there any missing value or the null values, okay, column wise. That's why I added over here is sum. Like if you wanted to go ahead and simply check the sum of missing values, okay, in this particular data set, so you can simply apply the sum again. Okay, so for that you will have to use this particular term sum, okay, and you can simply add this particular again. Okay, for this particular all the time you can simply add the sum over here. Okay, or not like this, because this is the, R studio, you can simply use the sum like this. Okay, you can use the sum like this. Okay, but here in R studio, what you can do is you can simply use the is dot na. Okay, so here if you see, okay, you can simply use this particular, which means that, okay, in this particular option, okay, if I, put my cursor to this particular option, you will see that why we are using this particular line of code. So basically, if in my data frame, if few values which are not available, also missing values we can say, so to find out those, we can simply this particular line of code, right? So that's why here you can see, if you wanted to go ahead with the next, so you can see that the next thing. Okay, see, next thing, again the same. If you go ahead with this, you can see, right? If you go ahead with this, you will get the, is there any missing values which is, like, which is there in the date time classes, which means this particular column. If you see, this is my column date time, right? So for now, we can simply go ahead with is dot na, and I can simply put my company's data. Okay, and let's go and run this. Okay, this is my company's data set. Now here you can see the option. Okay, now after this, let's go and run this. Okay, now basically if you see over here, okay, so like you will find that the false and true values are there. Okay, we got the values which are nothing but the logical, or you can simply say that we got the logical data frame now. Okay, why we are checking that? Okay, like, is there any null value present in my data set? So not the count, not the sum, for that. So for that, so you will see that the false, 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 which means that false means yes, there are no value for this, there is no missing value, this value is something which is there, okay, which is physically present in the data set. But if you talk about this true value, which means that yes, there is missing values. So you can see that in the 15th row, okay, like in the third column, you will see that the true value is there. So you can recheck over here. Okay, like in the, in the 15th row, you will see that in the third row, you will see that the na value is there. So that's why I got the, the true value over here. Okay, that is the thing over here. Now let us go over here. See, I just created the code over here, but not here, because I'll have to share this particular code with you now. So that's why I'm just copying this particular code, so you can, after you can use this particular code to hands on, right? Now, okay, we got this particular data set, but from this, if let's say if our data is quite big, so we can't handle this particular data, we can't just manually go and check false, false, true, false, true, false, true, we can't check that, right? So for that, we can simply go ahead over here and we can find out the, you know the sum for this, like for our each column we can simply say. So for that, we can simply use the s, how many missing values are there in each columns. That's why I'll be going with the s apply method, which is nothing but the s apply. And I can simply use my company name. Okay, see my company data set, if you see, and here I'll be applying one function on it. Okay, which is nothing but the, for that I'll have to create the function, okay, of, you can simply say of x, like, and then I'll be using the sum dot, okay, is dot na, and in the bracket simply apply it on each and every column in my this particular data set, right? So let us go and run this, and here you go. Like if you see, okay, I apply the s apply function, okay, or the supply, you can see, okay, on my company's data set. Okay, and I created the one function which is a very small function. Okay, and in that function what I'm doing, I'm just finding out the sum of how many null values which are present in my each column, okay, which is there in my data set. Now in the account number, okay, we don't have any null value. In the account name, we also don't have any null value. In the status, you will find that the four missing values. In the gross income, you will find that the zero null value or the missing value. In the num wages, you will find that the one missing values. Then for complete and for date, we don't have any missing value, right? Now after this, okay, like if we have the missing values, okay, So what we can simply do is, okay, like we can simply, there are multiple ways to handle the missing values. Okay, and what are those ways? Like, let's say if you have the missing values, so like if your data, like if your data is going to be it's not, see basically here, if you see, this is the function of x. Okay, this is the function of x I'm applying on my data set, which is company's data set. So basically what I'm checking, the sum, okay, of my all the, like like the missing values in my each column, and we are just finding out the sum for this particular data set. That's why I applied this function of x on my this particular data set. Okay, so it is not applying on this total data set, it is applying on each and every column inside the data set, right? Okay, now after this, okay, like there are multiple ways to handle the missing values, right? So whether you can simply ignore that missing value, so for that we can simply drop this particular missing value, right? Yes, x is nothing but the each and every column, so that's why you will see that the each and every column name and how many missing values are there in terms of sum, right? How many missing values are there? So if you see that the missing values, okay, like the only two columns, you will find that the missing value is present, right? Okay, now if we, like if we are dealing with the missing values, so there are the, you know, different ways to handle that particular missing values. One simple way to handle that particular missing value is to drop that particular missing values. Okay, but if you see my data set is very small over here. Okay, only 22 data points are there. Okay, right? So what I can do is, okay, I can simply go with my another way. Like I can find out the, you know, the either the mean. Okay, if my data set, okay, is the, you know, the numeric, we can simply find out the mean. Okay, and we are just try to find out the yes. Okay, s apply is nothing but just apply it on my, you know, the data set which is there, right? So that's why I use the s apply. Okay, so like we can, you know, replace those missing values by a mean, median, mode, depending upon our type of data set, whether our data set is numeric or whether our data set is, you know, the categorical. So if the data set is categorical, we can simply put the, you know, or the replace those missing values by using the mode. Okay, so let me, you know, okay, let me show you the different, the statistical terms that we saw in the previously. Okay, we saw previously as well, but few terms which are totally new, like mode, right? So as we know, mean is nothing but the average value. Let's say we have the data, let's say, okay, any data, let's say from 1 to, let's say, 100. Okay, if you wanted to find out the mean, we can simply go ahead and we can use the sum of x divided by n. So whatever the sum it is, okay, from 1 plus 2 plus, you will find that the 100, okay, divided by the 100 length of the all the data, you will find that the 100 data points are there. So that is nothing but the mean. If we're talking about the median, what is median? Like I am saying 50%, so which means that this is exactly my middle value, right? Middle value or middle number, you can simply say, right? So here my median is going to be 50, a center number, right? If we're talking about the mode, now what is mode? Highest frequency, right? Repeated occurrence, maximum number of time. If that particular value, okay, like occurred repeatedly, so we can say that that is nothing but the mode. Okay, that is not the highest value. We can say the, you know, maximum occurrence is there, or, you know, frequently occurred value, right? So that is nothing but my mode. Let's say in my this particular data set, like this is a 1 to 100 data set. So basically this data set is basically dealing with this. So if you're talking about the mode, so let's say if you have the data like this, 1 2 3 4, then we have 1 4 2 1 1 4, like this. So here you will find that, okay, the highest number of time one value is repeated in my data set, if you see, right? So that is nothing but my mode, right? That is nothing but my mode. Okay, maximum number of time any particular value repeated. Okay, so maximum repeated value in my data set. And why I am using the mode over here? Because if you see this term 1 2 3, which means that I'll be using these for categorical data, not for numeric data, because for numeric we have the mean or median, right? Now why mean and why median, when to choose mean and when to go ahead with the median? So for that, here if you see that, let's say if we have the data like this 1 2 3 4 5 and we have the data 100. Okay, so for this particular scenario, okay, like whether to go with the mean or median. So in that scenario, we'll have to check, are there any outlier present in my data set or not, right? So if let's say this 100 is the outlier in my data set, because if you see the common range or the normal range of my data set is going to be 1 to 5, and this value is very much bigger. So that is nothing but the outlier present. So at that time you can use the median, because if you go ahead with the mean, so you will find that the value of mean is going to be the 100 plus, right, then 1 plus 2 up to so on, okay, plus 5. So tell me the value of mean for this, okay, divided by 6. Okay, okay, so here if you see 115 divided by 6, okay, so total I can say that around 19 point something, if I'm not wrong, I guess 19 point something, right? So if we see that, okay, the normal range for this particular data is going to be the 1 to 5, 1 to 5, right? So if we have the outlier, so you will find that median is not affected, because you will see that median is this three value is there. If we go at the normal range for this particular data, again if we add this particular value, again also you will find that median is not affected, median is just 3.5. So you will see that it just very much less affected, right? You see, as compared to these, so if you talk about this 3.5 and 19, so which one is the, the best one? 3.5 is best one for this particular data. If we're talking about, let's say we have the data 1 2, okay, like this 3 4 5, then in that case if there are no missing, there are no outlier present in my data set, you can simply go ahead with this and find out the mean and add those mean values, okay, instead of missing values, which mean the NA value you can simply see, okay, right? So this is just the calculation. If you see, okay, like if you see that the 5, okay, 5, like if you calculate this, if you find out the sum for this, so the sum for this is going to be the, the 6 plus 9 is going to be the 15. So 100 plus 15 is going to be the 115, not the 108. Okay, these dot dots are nothing but add the 3 and 4 values too, because I am just finding out the sum for all this value 1 plus 2 plus 3 plus 4 plus 5 plus 100. Okay, now, okay, that is the thing. Okay, now the second thing, as I told you, you can simply and go and drop those values, right? You can simply go and drop those values, right? So for dropping, okay, because this is just the, pre-processing, I'm showing you how you can clean the data. So I'm trying to cover all the methods which are there, right? All the methods which are there. So here, okay, I'll show you how you can, go ahead and find out the mean for that, right? How you can go ahead and find out the mean for that. So let's say let's go and find out the mean for that, because if you see, this is nothing but the the status. So status is going to be the the categorical one. Okay, so you can find out the, okay, we can simply find out the mean for this particular column, right? So to find out the mean, we can simply use this mean, because there is only one missing value present, right? So mean of our the company data set, right? Dollar my this part this particular column, right? And here, as we know, there is one missing value present, right? There is one missing value. So if I added this particular missing value, okay, okay let's say if I have the the value like this 1 2, then we have the missing values, and okay 4 5. So if I include this particular missing value, because this value is not present, but my columns, how many length of the column is nothing but the 5, right? Sorry, length of the row is going to be the 5, which means 5 values are there. Yes, there is one missing value, but total values are 5, right? So while we are finding out the mean, so it will just add this particular value, which means 1 plus 2 plus 4 plus 5 plus divided by 5. So which means that our mean is affected by this one addition 4 plus 5. So for this one added value, okay, that is you know that is basically affected my mean, my final value, right? But if you remove this particular thing, so my mean is not affected by this, because you will see that the 1 plus 4 plus 5. So according to the definition, you will find that there are four values, and length of these four values, which is nothing but the 4, and you can simply find out the mean for this now, right? So for this in R, we can simply use the you know the NA dot remove, which means RM. Okay, just use this, and that is nothing but the true, right? Enter this and simply find out the mean for this. So mean for this is going to be the this particular value, which is nothing but the 21,608.52. Okay, that's how you can find out the mean for this. Now, as I mentioned, the second thing, like if there is a data, like if there are like there is a missing value present in your data, so how you can do this, how you can drop the data, how you can handle that particular missing value in your data set. So what you can do is you can simply go ahead and you can use the omit method, right? The na dot omit, which means that just omit those all the missing values which are present in your data set. Okay, so how you can omit those data set? You can simply go over here. Okay, you can simply go over here. You can simply use my na values, which means then the missing values, and use the omit. Okay, so here you can see that the omit function is there, which is already there. Just after writing few letters for this particular function, you will get the function, just enter it, and you will see that the you just like R Studio automatically completed your code. And now here you can use your data set name. So simply let's say if I go with this particular term, okay, if I go with this particular term, which means that I'm removing each and every missing value in my data set. Okay, so for that, let me show you. Okay, and I'll go ahead with the next term as well. Okay, so here I just omitted all the data set. If you see, right, uh, the missing values, those are present in my data set, right? So here if you see, let me just go and check the how many missing values now which are present. Like for that, I'll have to uh, name this particular data. So let's say this is my data. Okay, and let's go and run this. Okay, and now I can simply apply this particular code on this particular data set. Now the data set is nothing but the data instead of company's data. Okay, now here if you see, I can simply go ahead and run this. Now you can see that I just simply removed all the missing values. Okay, just simply removed all the missing values in simple words, right? So basically, okay, this is the one way you can just simply go and drop the your missing values. So let us go. We need our data, the original data. So this is my original data. Okay, because if you see now, we just created the two different data set, company data and my data only. Okay, that is a data. In the data you will find that there are no missing value present. Okay, now if you see, okay, now after that, after this particular line of code, okay, now there is no missing value in my data. If we use the data, if we use the company data, we have the missing values over in this particular data set, because total how many observations are there? 22 observations are there, right? Now there is another method you can do. You can simply go ahead with again the same na.omit, and you can use your company data, right? This is my company data, and whichever columns missing value you want to remove or omit, you can simply select that particular column name. Okay, you can select that particular column. Okay, let's say I just wanted to go ahead and remove this particular thing. So what I can do is I can simply use this. Okay, and here if you see, okay, now I just omitted the one particular value from it. Okay, no, in my status, okay, I guess there are four missing values. So for that, what I can do is I can simply just check, right? Sum is dot na, and in that I can simply add the you know the column name. Okay, dollar my status. Okay, that we used. Now here you can see that we have the four missing values, I guess. Okay, now here if you see, we'll have to again, okay, we'll have to check, we'll have to add the data one name for this particular data, and then we can simply check this. Okay, now for that, let me go and run this, and here you can now see, instead of this, okay, instead of this, we can simply use the data. Okay, so we can simply use the data. Now basically, I guess data is having only one, so no issue with this dollar, because if you see in the data, okay, right, not the data, it's data one, right? So if you see is in the data, we don't have any column, because you will see that data is the only single column we have, okay, in my data set, okay, in my data one. So let's go and run, and now here you can see that now there are no missing values, zero value is there. Okay, which means that we just omitted all the missing values which are present in that particular data, right? So that's how you can go ahead with, right? Then if you wanted to find out the median, right? So median, how we can find out the median over here? So we can simply use this, okay, median, and my any particular data set. Let's say I just wanted to find out the median of uh, this particular, this numerical column. Okay, now which, now let's go and here if you see that, okay, median for this is na. That's cool. Like if we see, let's go and use this, no, not this, I guess. Gross income, and let me go and run this. Yes, you will find that the median over here. Okay, because you will find that there are no missing values which are present in that data set, right? So for that, okay, you can simply find out the median for this. Okay, because there are no missing value present in the data set. First you will have to remove the missing value, then you can simply use this median. Okay, and you can go ahead with your further process, right? These are the few different things you can do with your data, okay, that I'm showing you, which is nothing but a data cleaning steps. Okay, there are number of you know methods, okay, depending upon your data. Okay, you can go ahead and clean your data. this is totally depends on your data. You will have to go and manually check the the what are the different things your data have or not. Okay, like outliers you can check the missing value. You can go ahead with the the different ranges of your data. Okay, whether your data is a categorical feature or numerical feature depends on as well. You can go ahead with, right? Okay, now after this, guys, next thing is to find out the duplicates. Okay, next thing is to find out the duplicate. So here, yes, and that we want, cleaning the data is basically affected the main file, and that we want because we are cleaning the data. Okay, so which means that basically we are removing the errors from the data set. Okay, and that is our main purpose. Okay, for our data science project, let's say, to like our data science project is to build the dashboards. Okay, find out the insights from that particular data, right? So at that time, okay, the cleaning the data is the you know the big thing we can say. What is the difference between company's data set and data? So basically there is just the, if you see, I use this particular company's data to read my original data set, right? And if you see the data, so there are no missing value present in your data. If you wanted to go ahead with the same name, like if you wanted to go ahead with the same name, I can simply put the same name too. Okay, this is just for your reference. Okay, just to understand, this is just for your reference. I can apply the changes on my original data set as well as my company data set. Just put the name, the company data set, and let's run this. Now here you will see that, okay, initially now there are 22 observations are there. Now let me go and run this particular cell. Okay, now you can see that only 18 observations are there, right? Only 18 observations are there. So basically my goal over here is to show you how you can make the changes in your company data set, because we are using the company data set and we are applying the different kind of methods on my company data sets, right? So that's why, okay, I just create the one new data set with the name data only, right? So basically if you see, the only difference between the company data set and data is nothing but, in the company data set, that data set is your raw data set, which is not the clean data set, and you're in the company you will find that at least there are no missing values, right? At least there are no missing values in your data. So that is just the difference. Okay, you can even go ahead and you can update the your original data as well. Okay, but here my intention to show you the how you can apply the different things on your data, right? Now how you can find out the duplicate data set. Okay, how you can find out the duplicate data set? So for that, for finding out the duplicate data sets, any idea for this? So if you wanted to find out, you know the duplicate, so you can simply see that, just put any, and you will see that the many different functions automatically pop up. So we'll be using any duplicated for this. Okay, and we'll be adding just the name of my data set, company's data set. Okay, so let's go and run this. You will find that there are only two values which are duplicated values, right? There are only two values which are duplicated values, right? Now you can go ahead with the different things as well. Okay, you can go ahead with the different things as well. You can you can simply use the duplicated as well. Okay, and you can use the company data set. Let's go and run this, and here you can see we got the output in terms of true false logical output we got, right? We got the output in the logical manner, right? Or okay, like if you just wanna remove the duplicates from your data set, and you wanna the data set and in that data set only unique values are there. So how you can do this? You can simply, okay, go ahead with your either your original data name, or like I did before, I can simply use any other data name. Let's say my df data frame, I can simply go with this df. Okay, so why I am creating this, this is just the name of the data set. Okay, nothing else. Okay, so I want my new data set, okay, which is having only unique values, okay, of my previous data set. So what I can do is I can simply use this, and I can use the unique method is there, right? So just by using unique method, I'll be adding my company's data set over here. See, and just use the control plus enter to run, and now here you can see this is my data frame. If you see, so basically I remove the duplicates from my data as well. Okay, I remove the duplicates from my data as well. Now you will see that basically there are two duplicated values, right? So we just remove this. Now the value is going to be the 16 because there are two duplicate values. Okay, so from overall 18 observations, if we remove the two duplicates, so basically we'll get the data of 16 observations, right? So that is the thing. Now, okay, like if you wanted to find out the unique values by using, like many times, okay, you don't wanna go with this inbuilt functions. If you wanna, you just wanted to go ahead with any particular library. So for that, what you can do is you can use the different libraries as well. Okay, and in R we have a very popular library which is nothing but the dplyr library. The dplyr library, let me show you. Okay, this particular library. Okay, the description for this dplyr library, which is nothing but a grammar of data manipulation. You see, a grammar of data manipulation. So here you can see the all about the grammar of data manipulation language, which is library, which is nothing but dplyr, right? So here you can see the many different things you can do. You can start by the apply function on across multiple columns. Sorry. So if you see that the second thing is you can add the columns as well. Okay, see, add columns, you can do multiple things. Okay, you can the count the observation in each group. Okay, then you can do filtering as well, right? You can do the filtering joins as well, you can see if you, okay, so then you can sort your data as well, right? So you can sort your data as well, you if you see, right? Likewise you can do multiple things. Okay, if you wanted to explore more about dplyr library, you can simply go ahead and check this. Okay, if you wanted to go ahead this, okay, just go ahead and check this, right? Now, okay, let us go ahead with this our thing. So for that, initially we can simply go ahead and use the dplyr library. Okay, initially we can simply import the dplyr library, right? So just import the dplyr library by using the library, and in the you know curve open bracket you can simply import it, right? See, I just imported it, and now after this, what we can do, we can simply go ahead and apply a distinct function of my deep library, dplyr library on my company data set. Like I created the you know the new data set, which is nothing but the df, right? And in the df there are no missing values, but in the company's data set we have the missing value. So now again let's use the company's data set instead of df. Okay, this is again to show you, for doing single things there are multiple ways. Okay, like many time, like if you see, like if you go with the any, like if you go for any interview, okay, so at that time, okay, they are trying to, they want the answer not in a specific manner. They want the answer in the, they want the, multiple answers, right? Like this way also you can do it, this way also you can do it, right? And why you are going with this, why you are going with this, right? Like this. So if we going with this particular library, which means that, okay, it's a, the, good way, because you see that the inbuilt functions which are just defined by the R, right? But the deep layer library is the aim of this particular library. In the name itself you will see that it's a grammar of data manipulation, okay, which means that it will, while you are working with a very big data set as well, so if you are using this deep layer library, it will give you the multiple data pre-processing functions, okay. So then you can simply use this library for the data manipulation or the data pre-processing, data cleaning in short, right? So here what we are doing is we are simply using the, let's say, unique, we are just creating a new data set, unique companies we can simply say, okay, because we are finding out the unique companies, okay. Now here you can use the, equal to, or you can use a alt plus hyphen, okay, this particular symbol as well. If you see many a time, the, in R, people are used to apply this particular function, okay, while they are creating any this particular symbol instead of equal to, right? So they'll be using alt plus hyphen for this particular, to get this particular symbol in it, right? So now here we can do it, we have the distinct function for this, okay, and here just use the company data set. So this is the one way, this is the one way to write your code, okay. What is another way? What is another way? This is the one simple way, like we also, doing this all the things. But if you wanted to go ahead with another way, so you can simply use first your company name, okay, company data set, and then you will use percentage, okay, greater than symbol, then percentage, okay. You will use this particular symbol to apply this, or you to create the, in short, the pipeline in R, okay. Like first what you are doing, okay, it's also easy to read your code as well. Like you are just uploading your data set, you are finding out the distinct values of your data set, right? After finding out the distinct value, you can apply any other function as well, you can apply any other function as well, you can find out the mean of your data set as well, you can find out the summary as well, right? But our aim here is to find out the unique values, right? So that's why we are doing it. So this is the thing. And to see the data, so you can see the unique companies are here, total 16 observations. If you wanted to see, you can see over here. See, this is my data, okay, the company data set is there, right? So that's how you can simply go ahead with, okay. Like there are many different ways, guys, right, to find out this. Like if you wanted to go ahead and select the particular column, and if you wanted to check this, so here in the distinct column, okay, in the distinct column, if you see, like let me copy this particular code over here, so you will be able to, okay, you will also get this particular code, right? So you will understand this particular code, okay. This is the thing. Now if you wanted to apply this particular function, this distinct function on your company data set, so you can, okay, like if you wanted to go ahead with singular particular column, so you can simply add the column name over here. Like in my company's data set, as we know, what are the different columns are there? So here if you see, what are the different columns are there? Account number, account name, status, gross income, like that we have the multiple columns. So let's go ahead with the, let's say, the account name, right? See, account name. Now here if you see, okay, what we are doing is Okay, we are just going with this and finding out the distinct value in this particular column. Okay, which means we are just finding out the distinct value for this particular column, right? So that's how you can go ahead and apply this thing on multiple, okay, like on like by using the multiple different ways, I can say. Okay, guys, do you know about the MySQL? Like we'll be learning that, like we'll be talking about that MySQL in the tomorrow's session, right? So if we're talking about the distinct, so like in MySQL we'll be using distinct to find out the unique values. So here also, like I mentioned, the the name for the data, unique companies. Okay, which means that we are just finding out the unique companies from this particular data set, right? I'm just finding out the unique companies from this particular my company data set, right? Or in short, the the unique companies or distinct companies, right? So that is it. Okay, nothing else. Unique means distinct. Okay, different from any other. Okay. Now after this, guys. Okay, let's see. Uh, let's say like I mentioned previously. Okay, like the data transformation. Okay, so which means that also known as a data scaling. Okay, so if we're talking about the data scaling, so like, okay, let me tell you one example, okay, about the data scaling. So like let's say take one example of, let's say we have the multiple columns, okay, in my data set. And let's say one column in my data set which is nothing but the, we can say, the age. Okay, let's say we have the employees data set, and we have the employees data set, then we have the name, we have the age, employee ID is there, we have the address is there, the position of the employee is there. Okay, the age column is there, the salary is there, right, of the employees. So likewise we have the several variables in my data set. So if we see the data set, so in your data set, let's just take the two columns, age and expected salary. Okay, just take the two example, the two columns from your data set. First one is nothing but the age, and second one is going to be the expected salary. So guys, what is the the common range of age? Like as we know, age starting with 0, newborn baby. Okay, then what is the upper level? Let's say 100. Okay, yeah, or let's go ahead with 80 or 100. Okay, so like I mentioned, 0 to 100. Okay, so let us go ahead with this. Now what is the range of salary, the employee salary? I am not mentioning any data set anywhere. So because we are talking about the example, that's why you can, yes, yearly salary, annually, right? So what is the salary of the employees? Let's say we have the data scientist. So what is the range of the salary of the data scientist? Let's say 7 to 11 LPA. So if we're talking about LPA, which means that 6 digit, okay, number, or if we're talking about 11 LPA, so that is nothing but a 7 digit number, right? So if we compare our age, which is nothing but the either 1 or 2 digit number, okay, and if we are comparing this with the 6 or 7 digit number, okay, and you are using these two same column, okay, to build the one model, right? You are using the age column as well as the salary column to build the one model. Okay, which means that if you created the model, definitely your estimated sal or that particular salary column is going to be your highest weightage column, which means that your model is totally biased towards your salary column because the range of the salary column is very high. Understood? So your range of your salary column is very high, so which means that model is just totally biased towards this particular column, and model definitely neglect the age column. Okay, if we're talking about the weightage is not same for both the columns. So to convert the unbiased data set, because of the weightage is not same for each and every column, so for we have to convert this particular data set, this particular two columns, okay, from, you know, not same weightage to the same weightage columns, right? And then we can simply go ahead with the building the model. Then at that time, the model we are getting, which is unbiased one, right? Which is unbiased one. So for that, okay, what are the different data scaling method, data transformations method are there? So if we're talking about, okay, so basically we will be using the, you know, the multiple methods, okay, like we have the standardized and we have the normalized method, right, for this. So let's see one of this, so for understanding purpose. Okay, so for that, what I am doing, I can simply creating one simple data set. Okay, one simple data set, let me create the data, right? Not this particular data set, so let me go ahead with the new name, which is the D1, right? This is my data set. Okay, now after this, what I am doing, I can simply use the data dot frame. Okay, here you can see one function automatically pops up, and here if you see, okay, we'll be using the data dot frame. Now let's say my first column name is X, okay, and I am saying that, okay, like in that particular column, okay, I'll be taking a, you know, the random numbers from the normal distribution. Like in R, to find out the random numbers, it's very easy, just use the R norm, which means that just we are just taking the random normal numbers or random normal variables. Now for that, how many random numbers we want from the normal distribution? Let's say 10 values we want. Okay, so then after that, we'll have to add the parameters of the normal distribution over here. Okay, we'll have to add the parameters of the normal distribution over here. So let's say my mean of the normal distribution is going to be, let's say 30, right? And my standard deviation of this is going to be, let's say 20. Okay, or not 20, 20 will be, you know, so much bigger, you will find that the variance is quite high. Okay, so let's go ahead with the point 2, right? Point 2 is standard deviation is nothing but the variance is 0.2. Okay, 0.2, which is nothing but a very small variance is that. Okay, now after this, let's create the new column. Okay, Y column, which is a new column, and now let's take a random numbers from any other distribution, let's say uniform distribution. So for that, I'll be using the R for random, unif for the uniform distribution, right? So I'll be using this okay, R unif, and then here again I'll have to mention how many values I wanna find out, which is normal one. The minimum value or the parameter here, if you see in the uniform distribution, there are total two parameters. First one is minimum and second one is maximum. So the minimum range for these values will be like, let's say let's go ahead with 3, and let's go ahead with maximum value for this, let's say 5. Okay, this is my data frame. Let's go and create this data frame. Let's go and run this and see, this is my data frame. Okay, so this is my X value. In the X value, you will see that the values, okay, which is around the 30, with the different, with the variance in that, which is nothing but 0.2, right? So that's why you will see that the difference, which is very less. Okay, like the 30.34, then 30.13, 29.99. If you increase this value standard deviation, let's say by 2, so you will see that the range will also increase. You will see the values like the 28, 32, like this, which means variation is also high, right? After this, okay, this is my uniform distribution, okay, which is the minimum range for uniform distribution. This is totally customized, okay, this is a customized one. You can take any minimum value, either negative, positive, no matter, you can take any positive value. But like if you are taking the minimum value, we should be minimum to your maximum value. Let's say if you are taking your minimum value as a 10 and you are taking as your maximum value as the 8, which means that 10 is not minimum than 8, 10 is maximum than 8. So that's why, okay, we'll have to take the minimum value which is less than your maximum values. Okay, so okay, these things you will have to remember. So this is my data. Okay, you will find that the data is between 3 to 4. Okay, you never see the data which is outside the 3 minimum value 3 and maximum value 5. So you will always see this data y values will be in, which is totally random, but these values will be in the range 3 to 5 because we mentioned the range minimum and maximum, and these are the two different parameters of the uniform distribution. Okay, and you see, like many times, okay, like for many different cases, sometimes client don't have the data to share with you. So at that time you will have to create your own data. Okay, you will have to go with the either survey or either simulation, you will have to go with and create your own data, because sometimes the problem will be very rare, let's say cancer. Okay, so if you wanna find out the, the data of the cancer patients, so it will be so difficult. You will find that, let's take a very rare cancer. Okay, like the cancer will be like someone got the cancer like in out of 1 million. So at that time to find out the patient data is very much difficult, it's very hard to find out. Okay, so to build or to do research for that, the medicine, to find out the medicine for that particular the cancer, you will have to go with the research first. So for that, for doing the research, we need the data. So for creating the data, okay, we will need this kind of distributions, right? Depending upon the, like the first we'll have to find out the which kind of distribution cancer, that cancer data is following, right? So like for, okay, and then we can simply use this term, okay, r unif or r normal or r exponential, depending upon any other distribution which is there in the statistics. You can use any distribution, okay, and you can create the data like this that I created over here. Okay, so it's not like that, which means like client like sometimes never give you the data, client only give you the problem statement. Okay, sometimes, not all the times. So which means that at that time you will have to collect your own data, right? So that is the thing. So for that we should know how we can generate the data. So that's how I generated my data. Okay, now I just wanted to go and do the, the data scaling, because if you see, this is my x data, the range of x data is between the, around 29 to 30. Okay, let's say 29 to 31. Okay, and the range of the y data is going to be the 3 to 5. Okay, so you see the tremendous difference between the ranges. Okay, so for that reason we can simply go ahead and apply the scaling. Okay, scaling is nothing but the, transforming your data into the same range. Okay, so let's say uh, just to show you, okay, I'm creating the, the data to, or I can simply use this name as the scale data, right? This is my scale data. Okay, to avoid any confusion. Okay, so this is my scale data. Now I can simply use this scale, okay, this particular function, and here you can see just put your data. Okay, just put your data. I'm just putting my data. Okay, and let's go and run this. And after this, here you will see, okay, we got the scale data. Okay, this is my scale data. Now can you tell me the difference between this particular my original data and the scale data? If you see, our original data is nothing but the range of x is in between 20, let's say 29 to 30, and the range of y is going to be the 3 to 5. But here in the scale data, okay, the range of x, the range of x is going to be -3 to +3. The same for the y. The range of y is also between -3 to +3, right? So which means that we just use this one simple word to convert my original data, right? So like, it's not like that data is small, so we can use this thing. It's not like that. If your data, let's say you have the millions of columns and all these things, right? If you wanted to transform your data into the single range, which is -3 to +3, also the range of the your standard normal distribution, so you can simply use this. This is also nothing but the one theorem in the statistics which is very popular, which is nothing but the central limit theorem, right? So see, basically just by using that theorem, this is just the, okay, the application of the theorem, central limit theorem. Okay, so here you can see that, okay, we have the two distribution. Okay, we have the two distribution, and if we apply the scale and we converted our data from any range. Okay, take any range, like here our range is nothing but the 29 to 30 and 3 to 5. Now you can free to take any range. You can take any range in thousands. Okay, you can take any range in lakhs or millions or billions, whatever it may be. Okay, you can take any minimum value, you can take any bigger maximum value, no matter. Okay, if you are using scale function, which means that definitely it will able to transform your data from, okay, in the range -3 to +3. Okay, that is the, application, power of central limit theorem, right? And we can, in simple words, okay, the power of your data scaling, right? So that's how you can apply this thing over here, right? Now guys, uh, let us go ahead and understand the, let's say, our data visualization techniques. Okay, because these are the few things. Okay, there are a lot of things you can do, depends on your data, right? If you wanted to more explore about the data cleaning, data data pre-processing, okay, for that you need to download your own data. Okay, let me tell you the few sites, like the open data is there, then we have the Kaggle is there, as well as you can simply data.government. You can take the data from the government's sites as well. Like that you can take the multiple data, right? You can use any, your data, you can use any data, okay, and try to clean that data. Okay, apply any different things, like try to find out the missing values, try to find out the outliers from the data, remove those outlier, or fill those outlier, depending upon your choice. Okay, it's totally, it's totally your choice to how you can clean your data. So that basically for building the model, right? So that is totally define your how your model is, right? Whether your model will be strong or poor model or moderate strong model, like that. Okay, depending upon the capabilities of your cleaning, okay, it will give you the model. Okay, you will see that the accuracy in the model. Okay, and see guys, this is the 80% of task. If you are working in the, as a data scientist, and you got the the project from a very scratch, you created your own data. At that time you will have to work on your data at least 80%, 70 to 80% of your total data science project duration. right? To clean and pre-process your data. And next thing is to just apply the models, because we know that already, the professionals created the algorithms, right? Right? They just created, invented the algorithms of machine learning, deep learning, and now you are seeing the algorithms of the LLM models you can see. So that is happen because of the transformer is again the one of the algorithm, right? So now if you are seeing the chat gpt and all, these are also the invented by the algorithms. Okay, you will find that, okay, like if you see the example about the chat gpt, you will find that they took the around 45 trillion, you know 45 trillion, we can say that the gb of data, not the 45 trillion, 45 tb of data they took to train the gpt, which is nothing but our chat gpt, not the chat gpt 4. Okay, they are constantly improving the chat gpt 4, right? Which means like we are just adding any prompt in the chat gpt, which is our free version we are using. Okay, we all have the access to that. So we are using that free version, so they are giving us the free version not because you are using it free. Okay, just because they have to collect the data from you, like what kind of, like the data you are just putting over there in the chat gpt. So that data is nothing but the the gold, like them. Okay, gold for them. And they will be using that particular data to build their new models like the chat gpt plus, gpt-4, right? So that is the thing. So data is important, and pre-processing is again the very important part for this. Okay, and after that you will see that the very less part of the model building, right? The 15 to 20% of your overall data duration. Okay, now after this, okay, like let's say you clean your data. Let's say you got you okay, you just clean your data. Let's say this is my unique companies, which are nothing but the clean data. Now how to you know download this data from here? How to download this data from here? So for downloading the data, we'll have to check the you know the we can say that the our working directory. So for that we can simply go ahead with, and we can see the get wd to see our working directory, present working directory. So let's go and run this, and here you can see my present working directory is this. Okay, this particular folder. Now what I can do, I can simply use, not I can simply use this particular term. Okay, which one? Just write, okay, dot csv, this one. I'll simply use the write dot csv, and I can simply use the unique companies, okay, data set, because I just wanted to download this data set from here. Because now this data is, let's consider totally clean data set. Okay, now I'll have to download this data set from the R. So for that I can simply use my clean data set. Okay, and here if you see, I can simply name it, like what kind, which name you want for this. So we can say that the clean, let's say, companies data dot csv. In which format we want? CSV format we want, because original data is in the CSV format. Okay, and now, okay, let's say here if you see, like in the unique companies data set, you will find that this particular column. Okay, this particular column as well. So okay, now we can simply go ahead with, and we are saying that the row dot names equal to false. We don't want it. Okay, we don't want it. So for that we can simply go ahead and run this. Now here you can see this code is executed, right? Now let me go and show you that particular data, the clean company's data. This is my data. Here this is my particular data, that is that we just clean, right? See, this is the data. Basically we initially we have the 22 columns, we just remove it, okay, because the data is, a few data points which are missing, then remaining the data is like this, right? That's how you can go ahead with, and you can do multiple things, multiple, seriously guys, like many things are there depending upon your data, the quality of your data, you can do the multiple things. Okay, so this is my data we just created, which is nothing but the clean one. Understood guys? This is how you can do the, data cleaning. Now let's move to the data visualization. Okay, now let us move to the data visualization, right? So for that, what I can do, I can simply use the comment for this data visualization. Okay, okay, yeah. By using which one? As we know, like we will be using the, data visualization here. If you see with the ggplot2, right? So we'll be using the ggplot2. Okay, and believe me guys, this library is so big. Okay, like if you wanted to see the library, so here you can see. Okay, let me show you ggplot2. Okay, this is the ggplot2. Now here if you see, okay, what it is saying, create elegant data visualizations using the grammar of graphics. Okay, using the grammar of graphics. So this is all we can do over here. Okay, use these multiple things. See, like later wise functions we have, later wise. So imagine, okay, like so many functions, and if you combine these all the functions, so see, try to imagine how many plots we can draw. See, later wise functions we have, right? So we can do so many different things, okay, with this particular data visualization library, which is nothing but the ggplot2. Okay, like basically we'll be going with the, few things. Okay, so for that, okay, we'll be using this term, okay, AES, which is nothing but construct, okay, aesthetic mappings, because with the help of this we'll be able to get the data. Okay, but before that, okay, like many times if you wanted to install this ggplot library, so you can simply go over here in the packets. Okay, like I already installed this particular library, so there is no need to install it. But if you wanted to install this library, you can simply go over in the install. Okay, and you can put the name ggplot. Okay, to here you can see this is my ggplot library, if you see, and simply click to the install. Okay, and it will automatically install your library. Now the second thing is that you don't want to go with this option. Okay, this is the GUI, you know interface, we can simply say. Now if you wanted to install this, you know by the code, you can simply use this code, install dot packages. Like if you see, this is nothing but the install dot packages we can, okay, we will be using, and in that just mention the ggplot2. Okay, that's it. Just run this particular line of code, and definitely, okay, this particular package will be installed by the R Studio. Okay, now for this, let me comment it out. Okay, so you can use this if you wanted to install this, right? So for that, I just comment this particular installation of the packages. Now let me go and import the library. For importing the library, I'll be using the library ggplot2. Let's go and enter this, which means run this particular line of code by using, either you can go and you choose the option over there, run, or you can use the control plus enter, right? Many times, like if you are a let's say R shiny developer or a data scientist, that is like for, like if you are using a ggplot2, then many times, okay, like you will have to create the few line of code, write the few line of code at that time. Okay, like you should know how to run the code by using the keyboard as well. Okay, what are the different keywords are there to run the particular code, right? So that's why in, like in between, like the session, I'll be telling you the things like how you can go ahead and run this, the your code by using the multiple ways, like either using the keyboard or simply use that particular option which is there, right? Okay, now guys, okay, we'll be using the another, we can say that the library, the data, not the library. Okay, so for that, as we know, we'll be using this particular data, which is nothing but the Titanic data for this particular topic, data visualization. So again, that this particular data which is already there in my getwd, which is nothing but my present working directory. See, this is the day6 folder, and in the day6 folder we have that particular Titan data set. So now simply go ahead and Titanic data set. Okay, so I don't want this capitalized word, right? So what I can do is I can simply use the Titanic name for the data. Okay, and then I'll be using the read dot csv. Okay, and inside it I can simply mention the name of my data. Okay, dot csv. Okay, and simply go and run this. Simply go and run this. Okay, now if you see in your data set, okay, let me show you the data which is nothing but the Titanic one. Okay, now for this, if you wanted to, if you wanted to clear your console, your plot, your all the history which is there in your environment, so you can simply do few things. You can go ahead in the console, you can use the control plus L. Okay, just use control plus L to clear your screen, because if you see that there are four different windows, right? So many times if you are not comfortable with all the data, which is all the code which is there, okay, like previous code is there, so that's why you can, if you wanted to remove that code or the clear that code, you can simply go ahead and clear this, like, okay, see, now we just created all these three windows, right? Now what we are doing, again we are just importing this, and we are just reading our Titanic data set. Now this is my Titanic data set. So in the Titanic data set, you will find columns are there in my like in the previous data set. Now you can tell me yes. Okay, so if you see the columns, so first column is nothing but the passenger ID, then survive, then passenger class is there. Okay, 1 2 3, like, okay, the name of the passengers, you will see their gender, you will see then age. Okay, then you will see the many different things. Okay, the fare, cabin, ticket, like this. Okay, now, okay, let us go ahead and explore our data. Okay, so for that, what we can do is we can simply go ahead and we can simply use a summary, right? Okay, and we can use this Titanic data. Okay, let's go and enter this. Now here you can see that this is my summary of my data. Okay, this is the summary of my data. So if you see that we don't see any NA values. So okay, NA values in my data. Yes, there is NA value. Yes, see this, see total how many NA values are there? 177 NA values are there for the age. Okay, for the age, right, in the age particular column. And for remaining columns, I guess we don't have any missing values. Instead of those column which are character, those column which are character, right, we just find out the NA value present or not in the numeric column. Okay, but here in the with the help of summary code we can't find out the, you know, is there any missing values in the categorical column or not, right? So this is my summary. Okay, now let us go ahead with the, you know, the structure. Okay, structure of my data. So let's go and control and enter, and here you can see. Now if you see the P class, the passenger class, this type of these is going to be the integer. Okay, but if we see the type of this passenger class is going to be the factor one, the categorical one. Okay, factor is nothing but the labels are there, right? The labels are there. Okay, so okay, we will have to convert this into the factor. Okay, then we have the second column, let's say survive column. See again 0101. Okay, person is survived or not? 0101. Yes, in this term 01 you can say that it's integer, but okay, if you understand this data, so you will find that survive yes or no, which means yes, this is nothing but the categorical data, and we want this data as the factor data type, which means the data with the labels, right? The data with the labels. Now after that, if you see that the sex is again the character, male female, we want this data into the feature, the factor, which means that we want the labels for this. Again if you see the embark class, again you can see the different things, because we'll be applying our, you know, the data visualization by using, okay, many times you will see that we'll be using this column. So that's why I'll be applying the factor on these four columns. Okay, so let's go and okay, change this type of the data from integer or character to the factor, right? So let's go and simply use the Titanic. Okay, let's go ahead with our, let's say, first column, which is nothing but the survived. Okay, I'll be using the survived, alt and hyphen. Okay, press alt and hyphen as dot factor. Now I'll be converting it into the factor. This is nothing but the casting in Python. If you see, okay, like if you remember what we did in Python for the casting, casting is nothing but, okay, it's give us the permission to change the data type into the integer to character, right? So that's what we are doing over here. Okay, now guys, after this you will find that very beautiful plots will be there by using the ggplots. Okay, so now let us go as dot factor. Okay, I'll be using the same. Okay, Titanic dollar survive. Okay, now you can simply use this because we are just converting our four columns, okay, into this. So that's why we need this. Okay, this particular code. Okay, so that's why now for each and every time I can simply use another one, which is nothing but the, let's say, P class. Now here I just wanted to use the next one, let's say, which is nothing but the sex. I just wanted to change. Now I just wanted to update the embark column, right? This one. Okay, and what I'll do, I can simply make the changes. Okay, same for here as well. Okay, right, and for here as well. So this is the thing, just go and run it. Okay, and go and run, just simply go and run. Now if anyone wanted to see this particular thing, so let me show you why we change this. Okay, so for this, okay, let me show you the type for this. Okay, class of Titanic dollar survived. Let me go and run this. So if you see, this is nothing but the factor. If you see, this is nothing but the factor. And if you wanted to see the data, so again let me show you the data so you will understand. Okay, all the things. Now you will see that the data in 0 and 1, 0 and 1, 0 and 1, but in the end you will see that the labels. Okay, you will see that the label. Okay, this is because of we just converted this data into the factor. That's why you will see that the labels at the end. Okay, and this is the thing, label 0 1. Like for creating the data, as we know, like we need to define few questions. Okay, like on the basis of that we can say that yes, we need to see this. That's why we created this particular plot. Like, so if you wanted to see the like what was the survival rate, okay, in that particular incident, in the Titanic incident. So let's say what was the survival rate. Okay, so for understanding this, let me just comment it out for because this is a just the question. Now we are just applying this. You can print anything, you can print anything, you can go ahead with p class and all. Okay, you will again find the same thing. Okay, nothing else. See, if you go and print the p class, you will see the levels 1 2 3, right? You can check by yourself as well if you want. Okay, definitely you will get the same output. Okay, now if you wanted to check the survival rate, okay, you will have to create the bar plot of the survival data, the survived data, right? So that's why I made the changes in the survived column, right? Now for that I'll be using the ggplot. Okay, ggplot, here I'll be adding the Titanic data, right? And here I'll be using this, right, AES. Now what does this mean? AES is going to be the the construct aesthetic mapping, right? So that's why we are using it. So basically in that we can simply use my first axis, which is nothing but the x-axis, because here if you see, okay, we are trying to visualize this all in the 2 dimension, right? So that's why x-axis I want the survived. Okay, I want the survived. Now here what kind of plot I want? I want the you know the geom AB line. I want area plot or bar plot. See, there are many options. If you see so many options are there, right? So here I want the bar plot. Let's go and run this and simply run this small line of code. Okay, if you run this particular small line of code, okay, let me go and run this. Okay, what is the yes. Okay, now here you can see. Okay, sometimes it might it may take few minutes. Okay, so if you see that, okay, this is my plot. Okay, now you are saying that this is just a simple plot we just plotted on the like in the Python as well. Okay, so if you see, okay, behind this there are a lot of different things. Okay, you will see that the the lines are there. Okay, grid lines you can say. Okay, the labels are here, survived, count, right? Like if you wanted to upgrade this, customize this, okay, by yourself, okay, so you can add the labels, you can add the theme to your plot as well. Okay, let me show you. You can add the title as well to your plot. Okay, but what okay, what was our question? What was the survival rate? If you really want to see the survival rate, you know survival rate into the percentage, then you can simply use this particular line of code. Okay, the proportion table, use these and in that just use the table and just apply it on the, okay, Titanic dollar my survive data. Okay, and here you can see the exact percentage of the survive rate. Okay, you will see that the zero means mortality rate, this is the survive rate, right? So 0.38, which means 38 out of 100 passengers, only 38 passengers survived, right? If we're talking about this range, so out of 100 passengers, only 38 passengers survived. Okay, and the mortality rate will be like 62 passengers, okay, died. So this is the thing, this is how you can go ahead with. Now if you wanted to customize your plot, okay, so let me copy this and use it over here. Okay, now what I can do is I can simply add the few terms. Okay, I can use the, I can add this particular term, which is nothing but the complete theme. Okay, complete theme. If you see, I'll go with the default value. I don't want to go with the parameters, because you will see that for each and every option there are lot of parameters, right? Then third one, I'll just have to, add the labels. So that's why I can simply use the label. So you can see that here okay, it will give me the permission to modify axis, legends and plot label. So if you see this all the things, so this is the, advantage of the Python, R Studio, because you will see that each and every time, okay, in the blue label, you will see that in the blue pop-up will be automatically come over then, and it will guide you like, now you will have to add this, you will have to add this, you will have to add this. Okay, now I'm just saying, just add the, the y-axis label. I want the label as the passenger count. Okay, now I want the title. Okay, now what kind of title I want? Let's say Titanic. Okay, survival count, right? This count, or you can say that the survival rate. Okay, we can simply go ahead with. So let's go and run this, and here you can see more proper way. In a more proper way, if you wanted to zoom it, you can simply zoom and you can see in the new, window. This is your plot. Okay, with the, the title over here, the, X label, Y label, you can see over here, right? You can do like this, you can do so many different things. See, you can do so many different things. Now after this, like, let me ask you another question related to, this particular. Now what was the survival rate by gender? Like, I just wanted to check the gender wise survival rate. Okay, so let me just copy this again, because the question is again, bit similar. Okay, survival rate by gender, that is nothing but the sex in this particular problem. Okay, so let me go and run this. Okay, so now here all the code is same, all the code is same. If you see the Titanic data we are using, we are on the x-axis. Now we want the, our gender, and here gender is going to be the sex, right? Then second thing is that, okay, I just wanted to fill all these, okay, because we want to check the survival rate na. So that's why I'll go and fill these, okay, by the survived, right? Second things, I'll go with the same line of code, okay, but here I'll just update this particular title, because now this is going to be the survival rate by gender, right? Okay, let me go and run these. and now here you can see. Now this is the plot, right? So here you just fill the, in the six, like the female and male, if you able to see that. Okay, let me just small, just change the size of this. Okay, so if you see that here the female, the male. So if you see the survival rate of male is very high as compared to the survival rate of female. Okay, so actually, like my bad. So here if you see the survival rate, so which is nothing but a zero. Zero is for mortality, okay, and one is for survived. So which means that if you compare this male and female by the gender, so you will see that the survival rate of the female is high, okay, as compared to male. Okay, because you will see that the, priority is there. Okay, like everyone wants to, protect her female, right? So that is the thing. So that's why you will see that the, the survival rate of the female is, high, and the survival rate of the male is low. So you will see that the mortality rate of the male are very high, which is quite high as compared to the mortality rate of the female, right? So that is the thing over, and that's how you can, uh, read this particular plot. Okay, so like you can do multiple things with this. Okay, you can do multiple things with this. You can go ahead and you can, do, different things. You can check the, what was the survival rate by the class of the ticket, right? So if you wanted to check this, so you can again use the same thing. Okay, you can again use the same thing. You can just copy and paste this. Like, let's say if what was the survival rate, okay, by the class of passengers. Okay, so here instead of the sex, what I'll be using, I'll be using the passenger class, right? I'll be using the P class, isn't it? And the rest of the code, you know code will be same, but here the survival rate by the, P class or the class of passenger, I can simply copy this from here, right? This is the thing only. You can simply go and run this, and now here you can see. Okay, again the very, interesting plot you will be able to see. Okay, now if you see the passenger class 1 2 3, okay, 3 is okay, which is nothing but the highest class, I would say. Okay, so if you see that the 1 2 3, okay, so there are three different classes. Okay, higher class, middle class, like this, or like depending upon that particular situation, first class, second class, third class, if you see. So the mortality rate for the third class is very high, if you see. Okay, and the, the if you compare the survival rate by the class of the passenger, so you will see that the survival rate of the class 1 passenger, okay, is higher than any other class of passenger, if you see over here. And the mortality rate is also low. See, mortality rate is also low. Here you can see that the, second class passengers as, are less, very less, we can say, as compared to the both classes. So it's like the 50-50%. Okay, and in the third class you will see that the mortality rate is very high and the survival rate is very low, right? But it's again more than the survival rate of the class 2. Okay, so that's how you can read the plot, right? And you can understand the many different things by the plot that you can't understand it by the numbers, right? So if you just plot this, so you can like easily understand this. Yes, right? So like that you can go ahead and you can use any different things. Okay, you can apply this all the things, see, ggplot is very high. Okay, like if you see that the documentation, you will find that a lot of things are there. Okay, so if you go and explore this all the things, which means that okay, we need to create a separate course for this, right, for ggplot only, because you will see that the lot of things are there. Okay, so my suggestion is to go ahead and explore the multiple things, like how you can do the multiple plots, right, how you can create the any different plots. Like I created now here the bar plot. Okay, now how you can create the different plot, like how you can create, let's say like I created the bar plot. Now how you can create the ribbon and area plots, how you can create the heat map, how you can create the heat map in 2 dimension. If you wanted to go ahead and if you wanted to this is the alternate way to create the bar chart again, like we created here by using the geom bar, right? So you can create this by using the geom column as well, right? Then how you can go ahead and find out the create the counter plot, right? So likewise you will see that the so many plots are there. Okay, just try to explore as many as possible, right? Now after this, okay, let's go ahead with our further topic. Okay, which is nothing but the basic statistics. What are the basic statistics we can simply do? So in the basic statistics, if you see, like there is a central movement is there. Okay, central movement is nothing but the mean, median, mode. We can just simply find out, right? So as we know, like how to find out the mean, median, mode, right? Mode is nothing but the most frequent value. So how to find it? We know that in the R studio. We know the how to find out the mean, how to find out the median, right? Then we know how to find out the standard deviation. Okay, like I can simply write this thing over here so you will understand. Basic statistics. Okay, so we know how to find out the mean. Okay, we can simply find out the mean of, let's say, Titanic dollar. Okay, uh, age. You can find out the mean of the age. uh, you know no, here we got the NA value. Why? Yes, might be sometimes if the NA value present, like as I told you, the NA value are there. Okay, in this particular data, so you'll find out that age. So that's why you will see the NA value is there. If you wanted to see, let's say fair. So let me show you the mean for this. See, mean for the fair is going to be around $32. Okay, at that time, right? If you wanted to find out the median, you can do the same thing. Okay, Titanic dollar, again we can use the fair over here. Okay, so you will see that again the median price for this is going to be the you know we can say that the $14. Okay, now okay, like there are multiple ways to go ahead with. Now we can find out the, let's say, we can find out the mode, or we can even find out the the variance. We can find out the standard deviation, right? So okay, okay, okay. Okay, because we are implementing mode on the any categorical data. So I guess we'll be using that particular thing on the let's say any column. Which column we just wanted to go ahead with? I guess let us go ahead with any column which is character, the mode. Okay, so what we can do is we just go ahead with the sex. Okay, or we can simply go ahead with the survived or P class. Okay, can. Okay, so like there is no proper function for this to find out the mode. Okay, so you can see that. Okay, this is the type of a, this is a storage mode. Okay, so now fair. Now we can simply create the function for this. Okay, we will have to, you know create the function for this. So for creating the function, okay, we should know how the mode is nothing but the most frequent value of, okay. So here if you see, we can simply go ahead with like, okay, mm, like let's say get mode. Okay, we can create the function of, let's say function of v, or we can, you can go ahead with whatever like x and all, right? Then we are checking the unique values. Okay, the unique values from this. So for that we'll be using again unique function of x. After this, okay, we'll be using this, okay, unique, this particular function that we created above. Okay, and in that we'll be checking that which, okay, like which particular, the values which are there, which are having a very high value, okay, which is repeated maximum number of time. Okay, so that's why I'll be using a tabulate. Okay, in the bracket, if you see that we are trying to match the, you know our the data, which is nothing but the v. This is not the x, this is the v. Okay, like you will have to use only one letter if you go ahead. Okay, and unique. Okay, uh, you can simply use a unique because we just created this thing over here. Okay, just to avoid confusion, we can simply use the unique as well, like if you want, like this unique. See, because these two terms, this is the function in R, and if we use the same thing, like it might sometimes it might be confusing, right? So let's go and run this. Okay, so we just created the function. Okay, so at that time, see, v is not found, but like after creating the function, okay, like we'll be using the get mode. Okay, get mode, we just created the function. Okay, and now what we are saying is just find out, let's say, uh, uh, the mode for the, you know 6. Okay, dollar. Okay, now let me go and run this again. I'll have to run this thing. Yeah, and let me go and run this. I guess few things which are not matching. Yeah. Okay. Like the one more thing, like as we know, okay, if you're talking about the mode, which means that we have to find out the maximum number of time that particular value repeated. So here we'll have to add the which dot maximum value. Okay, then it is, capable to get the mode. Okay, now see, mm, like simply get out of from this browse one. Okay, and let me go and run this, and now here you go, let's go and run this. Okay, get mode, table is missing, I guess. Mm, okay, I guess. Okay, let us go ahead with the survive for now. Okay, and let me go and run this. Why it is, making this thing. Okay, And if we go with this, okay, I think some uh, hues with this. Okay, yeah. Yes, we'll have to convert this particular thing into string to numerical. Then it will take, because if you see over here is you know like we'll have to convert this from string to integer. So what I can do is I can simply use these. Okay, instead of using this, we can simply use any numerical value, right? Then simply use this sib sp. Okay, sib I guess, which one? Okay, sib sp. So then simply use this sib sp and let's go and run this. It's on the browser, my bad. Okay, now here I guess it might work. Okay, no worry, we'll figure it out, I guess. Okay, so after this, okay, you can find out the variance for this. For that we'll have to, okay, we'll check the numerical value I guess, because all the data is quite we'll go and find out the variable for variance for this particular fair. Okay, variance is nothing but the variability in your data, right? So for that you can go ahead and use these, okay, and see the fair. Okay, and you can find out the variance for this, right? After this, uh, like if you wanted to find out the standard deviation, okay, so you can use this SD and again use the same thing. Okay, Titanic dollar, the fair one. You can go ahead with and run this. See the, again you can see the standard deviation. So you can do the so many different things, which means, okay, you know these are nothing but the basic statistics. You can find out the mean, median, mode, you can find out the variance, standard deviation, and so many different things, right? Now what about next? Like let me show you how you can do the advanced statistics, which means how you can go ahead and find out the some regression, ANOVA, analysis of variance, right? So for that, okay, like as we took the one data set which is nothing but the WC80 data set, our the simple linear regression data set, that data set I'm gonna use over here as well. So for that, okay, let me go and basically use this particular data. Okay, WC80 data set, I'm gonna saying that read dot CSV. Okay, and then I'll be using this particular data, which is nothing but the, over here if you see in the data set, which is nothing but the WC80 data set, and I'll be using this particular data set. Okay, now just use the WC, okay, 80 data set over here. Okay, dot CSV. Okay, and simply run this. Okay, as we know, this is my data, and in my data there are two column, waist column and 80 column. Okay, so on the basis of waist circumference, I'll have to find out the model which can predict the 80 adipose tissue data set. As we discussed this all the things, this problem statement in the previous session. Okay, so that's why I'll be using this particular same thing over here, right? So we can simply go ahead and simply, as we know, we did the multiple things over there, like we find out with the summary of the data. We plotted this several plots, like the histogram box plot we plotted. But for now, what we can do, we can simply go ahead and simply build the regression model, right? To just show you how you can build the regression model, how you can do the advanced statistics in R as well. So for that, we have the one basic method for this. Just go ahead with and put the name, okay, for the regression, and use the LM. LM is stands for the linear models over here, right? So now, okay, we can simply go ahead with and use our data set. Okay, WCAT. Okay, like there is another way as well. Let me show you the one way. Okay, we have the one method which is nothing but the attach. Okay, if you know this method attach, which means that you can simply use the column names instead of mentioning the data name. Okay, so what I can do is I can simply use the WCAT, and just by running this, okay, it will be, now I can able to use the column name instead of the, like the first I'll have to mention the data, then dollar, then that particular column name. Instead of this I can simply use the column name now. So 80 is my one column, and you know then we have another column which is nothing but the waste column, right, comma my data. Okay, so because we use this particular term over here attached, so now no need to use any data and all. So because, okay, now it is automatically taking this data set, okay, from this, these columns from this particular data set, right? So that's why simply use this term and go and run this, right? Now after this, use the summary. Okay, and if you know the summary, so you can simply go ahead and apply the regression. Now you can see the summary of my model. Now as we know, okay, there are few different things. Okay, in Python we got the summary in terms of first the evaluation matrices, then we got the summary. This is my second table in Python. Okay, as we know, the t value are there, the p value of the t tests are there. Okay, so we can say that just by here looking at this particular thing, we can say that, okay, our column, each and every column which is there, which is the significant column, because the p value which is again very much less. Okay, 2 into e raised to minus 16, which means that it's very much close to 0, right? Like if you wanted to see the code of the significance over here, so you can simply see the code of the significance. See, if we have the only one star, we also say that this particular column is the significant column, right? But here we have the 3 star, which means that the column is very much significant, right? The column is very much significant. Okay, that's the the good way to understand this thing by using the significance code over here. Now the second thing is that if you see the r square, okay, as we know, we got the r square over there around 67%. Here also we got the same r square, which is the 67%. Okay, adjusted r square is nothing but the 66.7%, if you see, right? Then this is f statistics is nothing but your analysis of variance. If you wanted to cross check, what you can do is, okay, we can simply go and check this. Okay, we can simply go and use a ANOVA, okay, analysis of variance over here. Okay, and basically with the help of analysis of variance, what we are checking, we are just checking the significance of my overall model. Okay, here because we are applying the whether the one particular column or the multiple columns, okay, depending upon the data. Okay, here we have only one independent column, one dependent column, so that's why we can simply say that, okay, we can simply go ahead with the single term as well. But if you have the multiple data, multiple columns in your data set, so you can go ahead with the ANOVA, and you can see that whether your model is significant for making your further prediction or not. So you can check it like this. Okay, so if you see over here, okay, in the regression output, okay, you will get the ANOVA value, the f statistic, direct the final result you will see, and the p value for that. So here also, okay, this is the explained solution, I can say. Okay, explained solution of the analysis of variance, which means that you can understand the different terms. Like someone asked me in the previous session how you calculate the r square, right? So the formula for calculating the r square, which is nothing but 1 minus sum of square due to residual divided by sum of square due to total, right? So here you can see that we got the sum of square due to residual. Okay, sum of square due to residual we got, and if you add these two value, this value and this value, you will get the sum of square due to total. Okay, now you got the two value and you can simply find out the r square. You will get the same result if you wanted to check. See, okay, and if you wanted to check this app statistics, you can see the app statistics over here. Okay, if you see this thing 217.3 and this 217.28, if you round this to one decimal point, you will get the three value 2.17 217.3 value, and the p value is again same. See, the p value is less than 2.2 into e raised to minus 16, so again the same value. Okay, this 3 star means, okay, your model is significant. Okay, your model is significant. So behind this there is one hypothesis testing. Okay, is that, which is saying that in the null hypothesis you can say that the your model is significant, and in the alternative hypothesis you can say that your model is not significant. So you can simply use that and you can say that your model is significant like this. Okay, so that's how you can apply the, you know, the analysis of variance on that, right? Like we'll be talking about the, you know, the mode in the upcoming, we can say that the tomorrow session, right? Okay, so thank you guys, thank you very much.